We do a lot with electronics. I mean, everything from entertainment, electronic game, to telling the time on the electronic crazy clock, or reading your brain waves on the electronic computer. There's probably, I don't know, a million other ways we use it. We won't get into at the moment. So, every circuit does its job using a variety of components, right? Right. Resistors, diodes, capacitors, transistors are all brought together to perform a greater function. Even though these devices perform different jobs, they often need to complete very similar tasks along the way. So instead of building, say, a timer circuit, using all the individual parts it takes to create that circuit, we would instead have it pre-assembled, integrating the circuit's parts into one little chip. Hence the name, integrated circuit. But you can call them IC for short. He doesn't really mind. ICs are pretty commonplace nowadays. Black, square, rectangular, metal pins for legs. Through-hole or dip ICs are relatively longer and larger, sporting these long pins for mounting through the holes of a PC board. And then there's the very compact surface mount type, which you can tell by their size and the fact that the legs go flat like that in order to be mounted on the surface of a board. Many chips can be damaged by connecting the power backwards or by electromagnetic discharge. Here's one that I myself damaged by, connecting the power backwards, I think. It made a nice little pop, fizz, and a little wisp of smoke with a stink. I could pull it out easily and replace it because I mounted it in a socket. Now, instead of soldering the chip onto the board, you pop in the socket, solder that, and then you push the chip in. And if you want to remove it, you just pull it out. Long before the first chips were ever manufactured, the concept for the integrated circuit was just a twinkle in the eye of British scientist Geoffrey W.A. Dummer. In the early 1950s, Dummer spread his very smart idea, describing it as electronic equipment in a solid block with no connecting wires, consisting of layers of insulating, conducting, rectifying, and amplifying materials. That could be a description of basically what we use and build upon today. His attempts to create a prototype IC of his own didn't pan out. The first IC, or the first ICs, I should say, were invented by two researchers working simultaneously. Jack Kilby of Texas Instruments used germanium as the chip's substrate. Robert Noyce's IC, made at Fairchild, was constructed from silicon. Computers quickly made use of the new technology, replacing large arrays of transistors with monolithic designs. Jack Kilby's first IC held one transistor within it. Nowadays, chips are made that can contain hundreds of millions of functional transistors. When working with any new chip, the first thing you'll want to do is have a look at its datasheet. Essentially, an IC's owner's manual. Datasheets can usually be downloaded from the chip manufacturer's website. Otherwise, Googling the part number will almost always turn up a helpful PDF file.